In this video, which is part of the advanced refrigeration course, we're going to be talking about refrigeration components. Now, pretty much this is a lesson just so that you can identify the components. We're not going to do a lot of discussion about each component and what it does and how it works, but this is more of a component identification. Lots of pictures in this. We'll talk a little bit about it as we can, but there's other portions of the course where you're going to have more practice with this. So, our refrigeration system, okay, has four basic components that are in every refrigeration system. Okay, we have the compressor, of course. We have the metering device, okay, which is over on right there. This is a TXV in this case. So we have compressor, metering device. Those are my 2 points of pressure change. We have my evaporator and we have a condenser. Anything other than those two components can be additional to the system, may or may not be there. Okay, so what we're going to be talking about is some of these additional components. So the first additional components is the evaporator pressure control, or EPR. It's actually evaporator pressure regulator. The EPR valve will modulate the flow of vapor refrigerant leaving the evaporator. It limits the pressure in the evaporator and keeps it from dropping below a certain set point. You see EPRs when you have multiple evaporators. Okay, if you have more than one evaporator hooked to a refrigeration system, you will most likely see an EPR in the system. And it does have a Schrader valve port, so you can actually set this based on the pressures you need to have in that evaporator. Okay, we also have, okay, and this is just how they're piped, okay? So on the outlet of each evaporator, you have your TXV coming into the evaporator. You have an EPR on the outlet of the evaporator. Okay, the evaporators pipe together and one compressor is used to maintain the suction pressure for the lowest pressure evaporator. Evaporators that have pressure higher than the true suction pressure of the lowest evaporator will all have EPR valves set to their individual needs. This is how supermarkets are able to maintain cases with different temperatures using a single refrigeration system. The crankcase pressure regulator, or the CPR, is found before the compressor. Okay, it allows us to maintain a set pressure in the compressor crankcase. Okay, so what we do is we have our TEV or TXV, we go to our evaporator, and then we come out here to the CPR, and this allows us to maintain a specific pressure in the crankcase or in the compressor inlet side. Sometimes we have a sight glass. We'll talk more about this when we talk about refrigerant pressures and charging refrigerants. Primary purpose of a sight glass is to tell you if there is moisture in the refrigeration system. They all have a moisture indicator that either tells you if there's moisture or if there's no moisture. Used to be with some of the older refrigerants that we could tell if the system was undercharged by bubbles in the sight glass. This is no longer the case. If you have bubbles in a sight glass, all it means is that there's refrigerant in the system. If there's no bubbles in a sight glass, all it means is the system is either full or empty. Because refrigerant, you cannot see if that sight glass is full. Primary purpose of a sight glass is to check for moisture in the system. So there's different types of sight glasses they all have moisture indicators. When you braze a sight glass in, if it's a braze or sweat connection, make sure you put some heat absorbing material around it. I normally use a wet cloth. Other people use paste and stuff like that. You don't want to burn the moisture indicator with the heat you need to use. Some systems will have a pump down solenoid. Okay, a pump down solenoid, all it does, it's controlled by the thermostat, and it allows the system to pump all of the refrigerant into the high side of the system. And it holds it between the compressor and the metering device. Okay, it holds it before the metering device so that there's no liquid refrigerant that can migrate to the evaporator during the off cycle. Sometimes we also have a hot gas solenoid. Again, when current flows through the coil, the iron bar in the solenoid is attracted to it and it opens the solenoid valve. Now, a hot gas solenoid is in the discharge line of the compressor, and it allows hot gas from the compressor discharge to bypass the condenser, the receiver, and the metering device and dump directly into the evaporator coil. In most refrigeration systems, we have a receiver. All the receiver is a reservoir to allow us to make sure that we're always sending liquid refrigerant to the metering device, but we also use it to house the liquid refrigerant when we're in the pump down mode. And you'll see a cutaway here of the receiver. Okay, liquid line from the condenser is at the top of the receiver, and we have a dip tube that goes to the bottom of the receiver that our liquid line to our metering device comes out of. We also normally throw a king valve here with a gauge port on it. It's a three-way valve that allows us to front seat, back seat, or mid-seat a king valve so we can service, shut off, or isolate parts of the system. We're going to talk more about the three-way valves in a bit. Some systems will have a fusible plug in it. This is a pressure relief. In larger refrigeration systems, we use a high pressure relief that's made of a fusible plug. Okay, the inside core of that plug will melt and will blow out under certain high pressure, high temperature. Only way to fix it is basically to replace the plug with a new plug, find the problem, correct it, and then you get to charge it. You get to do an evacuation to pull the air out of the system and then recharge the system. We also have spring-operated pressure relief valves, okay, where if the pressure gets too high, the spring will push up and it will open and it will dump refrigerant out of the system. Again, once the refrigerant is dumped, it's gone, okay? It dumps someplace outside of the building, and it will dump until the pressure drops to a certain point and then it will seal itself. However, you then still have an undercharged system and you have to find and correct the problem. We have different safety pressure relief valves. Different manufacturers do it in different ways. Okay, if your system has them, you have to find it, usually replace it, and correct the problem, evacuate the air out of the system, and recharge the system. Of course, after you leak check and everything. Oil separators exist as well in larger systems. In most systems, in the smaller systems, the oil flows around through the refrigeration circuit completely through and mixes with the refrigerant. In larger systems, we want to separate the oil out from the refrigerant as it leaves the compressor, okay, and sometimes as it leaves the condenser. But we want to separate that oil out of the system. So what we do is we have the hot discharge gas coming in from the compressor, okay? We then pull the oil out because the oil separates to the bottom, and we send the non-oil to the condenser, and we return the oil to the compressor. And again, all it is gravity-based. The oil falls to the bottom. The refrigerant is lighter than the oil. The refrigerant moves on to the condenser. The oil gets returned to the compressor. Has a float valve in it that shuts off the oil return if there's no oil in the separator. Okay. And again, this just shows how it could be piped. Okay, we have an oil separator and the number A up here at the top. That's what it looks like. Okay, we have hot discharge gas coming from our compressor. That contains oil because the oil is in the refrigerant. We separate it off. When the oil separator level goes up, it pushes it back to the compressor. The refrigerant without the oil moves on through the condenser and through the rest of the system. Some of them actually have fins in it to have this happen in a faster manner. Okay, but again, they're still piped the same way. 3 lines. Discharge from the compressor, discharge to the condenser, oil return line to the compressor. And you don't see these that often on smaller systems. These are mostly found on pretty large systems. Okay, sometimes we have what's called as a rack system. Okay, we again separate the oil off. This is just another way to do it, and we return the oil to the full system suctions. Okay, so the oil goes back into all the compressors. Okay, this is called a rack system. Multiple compressors on a suction header and a discharge header. Okay, and the oil in this case is separated out before it goes to the before the refrigerant goes to the condenser, and then is returned to the common suction header. So all the compressors continue to get oil back to it. We have sometimes a heat exchanger. What this allows us to do is reclaim some of the heat. Okay, I'll take a look at the next slide here of how it's piped. Okay, we have heat, we have liquid refrigerant from the receiver, and then we exchange the heat with the suction gas. Okay, in other words, this allows us to cool the suction or the liquid refrigerant a little bit off before it comes back to the metering device. Improves our efficiencies. We have vibration eliminators on larger systems. The vibration eliminators are put between the compressor and the evaporator, and the compressor and the condenser. What this allows us to do is actually eliminate the vibration from a larger compressor in the system. This is a woven metal, usually with rubber on the inside. The woven metal helps us handle the high pressure. The rubber seals the system. If you have to braze these in, be very careful about heat. Okay? So again, this is how they're piped. Okay? The discharge line is fastened to a solid object. We use a vibration eliminator here. We fasten the suction line again. We use a vibration eliminator. Okay? The inside is a bellows-like interior with a wire mesh covering. Solder connections on each side. Make very sure that the vibration eliminators are always in a straight line. You never want to mount them in a curve. So you never want to do like a 45. They need to be kept straight. They can either be horizontal or sometimes vertical. Do not ever mount them at an angle. The accumulator is before the compressor. It takes suction gas in, and then it allows only gas to go back to the compressor. Okay, because we don't want any liquid to go into, okay, we don't want liquid to go back to the compressor. Okay, it holds liquid and it allows it to vaporize off. You see these very frequently in heat pumps, okay, in cooler climates. You'll find an accumulator. Okay, so again, this is just a picture of an accumulator. Okay, this is a suction line accumulator with a heat exchanger. So again, here we're pumping the liquid from the condenser through it to allow it to cool off. And it does two things. It boils off any liquid refrigerant in the accumulator because of the heat that we're pulling out of the liquid line. And it cools the liquid to the expansion valve. In most systems, we will have a liquid line filter dryer. Okay, it's someplace in the liquid line after the condenser, before the metering device. Okay, they do have directional arrows on it. Do not put it in backwards. Okay, so you definitely want to look for the arrows. Most heat pump systems have bidirectional filter dryers. They're slightly more expensive. That's why you don't always use them on refrigeration systems. Okay, so they're made, and you have to watch because they're made for specific refrigerants and specific pressures. Just watch your directional arrows. So the refrigerant always flows towards the metering device. Okay, if you put it in backwards, there's no catch here. There's no way to prevent the material in the filter dryer from going out that other side. Okay, so this is a very directional operation. And there's different water absorbing capacities based on the size of that filter dryer. That's why it's important. And different refrigerants have different requirements. Sometimes we put a hot gas muffler on the discharge of the compressor, and it very specifically says it needs to be horizontally installed. Okay, all a hot gas muffler does is cut the compressor noise in a very large compressor. You see these in big supermarket systems, big cold warehouse systems, because a compressor can actually make a lot of noise, and we need to cut that noise for safety or for environmental reasons sometimes. Okay, you have in and out when you have baffles in there that act as a muffler. We sometimes put check valves into systems. It allows one-way flow of refrigerant or oil. All it does is make sure we don't have reverse operation. The pressure differential pushes a valve or a bearing open and prevents backwards operation or backwards flow of refrigerant. Sometimes we put a suction line filter dryer in. Okay, a suction line filter dryer, again, is very directional and has a removable core. Okay, the reason we use these is if we've had a compressor burnout in a large system, we might still have acid and contamination in the system. So we want to capture that before it gets to the compressor. So we use it on the suction line between the evaporator and the compressor. This is just another example. Okay, we have two gauge ports on here because we can actually tell if this filter is clogged up by the pressure difference between these two ports. By putting a gauge here and a gauge here, we can tell if this filter dryer is starting to get clogged up with debris because we'll have a difference in pressure. Okay. And this just shows how we would do that. Just another suction line filter dryer, a couple different versions. And again, the gauge ports are pretty important. Sometimes we use a low ambient control. Okay, all it does is it allows us to bypass hot gas around the condenser. So if the pressures get too low because of low outside temperature or low temperature air around your condenser, we can actually allow some hot gas to bypass around the condenser. So this is how it's piped, okay? So our normal flow of refrigerant comes out of the compressor into the condenser, through the condenser, and into our receiver. The low ambient control, or headmaster, senses if this pressure drops too low in the system, will actually open and allow some hot gas to bypass directly, which effectively increases the pressure of the system. Now this is important because we have to maintain an evaporator pressure. If my high side pressure drops because it's too cold outside, my evaporator temperature is going to drop, and I'm going to lower, and we could freeze up evaporators or just make it less efficient. Okay, so by bypassing some hot gas, I can increase my pressures to maintain that evaporator temperature. Okay, and this is how basically everything we just talked about works into the system. Low ambient discharge pressure control. Again, this is just a set one here where we know I could pipe it in between the evaporator or between the condenser here and the compressor. and I can actually force a specific pressure to be going into the liquid line, which comes through to the TXV. Okay, this is a hot gas bypass. Okay, hot gas bypass using liquid injection valve. And again, we have a compressor discharge, and I can bypass that hot gas to get it back to the compressor. Okay, so we bypass here, and we can bring it back right in, okay, to maintain pressures. Okay, another hot gas bypass to the evaporator. This is what we're talking about when we do hot gas defrost. My discharge line has a T in it with a solenoid. Okay, I can bring this right around to my evaporator and mix in that hot gas into the evaporator after the TXV. Okay, brings hot gas into the evaporator. So again, if we go back to the first slide way back at the start of this presentation, okay, we have different components that show up in different places in the refrigeration system. Okay, we have our discharge mufflers, we have our suction accumulators, we have oil separators, we can put check valves in to prevent backwards flow. Okay, we have a condenser, which is a permanent part, we have a receiver, we have suction line filter dryers, okay, we have moisture indicators, okay, well, suction line filter dryer over here, okay, we have different things that might show up in different systems, okay, oil level regulators, okay, so just be aware that just because we have the 4 basic components, you might have more than those 4 in a system.